So this video talks about the standard form of a line as well as the intercepts for lines. Now the intercepts are just, they're not dependent on being a line. A curve or another function can have an intercept. So it's not limited to just lines. But the point where a line crosses an axis is known as that axis's intercept. That's kind of, it makes sense when you cross paths with somebody, you intercept them. Sometimes police cars are known as interceptors because they try to cross the path of the bad guy. The value of the other ordinate. So in my very first video on little simply what's happening here, what's it called, how are things labeled, that sort of thing, I called this a Cartesian coordinate plane. Coordinate is kind of a prefix and then a word. Co meaning two. They're both kind of equal. But ordinate refers to the actual values. So the x value on the x-axis is known as the x-ordinate. Back in the day it was known as the abscissas, but we've kind of just made it to ordinate. The y value was, in the old days, known as the ordinate. And now it's also still kept the ordinate name, which is why it's co-ordinate. There's two of them. Okay. Here we go. So if we want to find the x-intercept, for instance, the place on x where it crosses, we might have a point here. And if we had a line passing through that point, doesn't really matter what the equation of the line is, it's just a line, it's just cruising along, then we can say that its x-intercept is equal to, now the something here refers to the x value. The x value will change. So in this case we have -5. The y value of the x-intercept is always 0 because the axis, the corresponding axes, are 0 on the opposite ordinate. So if we're talking about the x-axis here, the horizontal one, then the y value is always 0. Always, 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 forever, never, never, amen. And then somebody's going to be like, yeah, but when you graph it in upper mathematics and you talk about the real number system, the complex number system, you talk about unaries, okay, all right, it might change. It's not what we're talking about. Anyway, the y-intercept. Let's say we kind of extend this thing and it just keeps going. Wow, that is not going to keep going like that. That is terrible. You should feel bad for being that bad. But let's say it just kind of keeps going and apparently makes a little turn. And then crosses up here. This is the y-intercept. You are crossing the y-axis. So sometimes it's just y-int for y-intercept. Now the x value of the y-intercept is always going to be 0. Always, 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 forever, never, never. And then you find out what the value is when it crosses the y-axis. That goes in the y slot. So this is what the intercepts do. Now if you want to find the intercepts and you're not given them because you're not given the line on a graph or that sort of thing, you can find them in the equation by simply setting the appropriate value to 0. So if I wanted to find the x-intercept of a line and I had it in, well, standard form is actually the easiest to work with this, but you can do it in any form. If I wanted the x-intercept, I just make y 0 and then solve for x. If I wanted the y-intercept, I make x 0 and then just solve for y. You're done. Ta-da! Now, where does this come in handy? If you can use it in the standard form, your life will be so easy. So let's just make up some kind of an equation here. Let's say it's 3x plus 2y is equal to 6. Now, what does this look like? Oh. But apparently if we take 3 x's and add 2 y's to it, we get 6. So I can, in fact, find the axes, or the intercepts on the axes, by creating my little t-table here and making a choice. The choice I'm going to make for the intercepts are, for my x-intercept, I make y 0. So if I choose y to be 0, that forces this whole piece to go to 0, because 2 times 0 is just 0. Now I need 3 times something is 6. Well, that's 2, so x is 2. So the point 2, 0 is on that line. And you're like, yeah, but wait. Okay, we'll mark it. And yeah, but wait, can we do it the other? Absolutely. you just make x 0 for the y-intercept. When x is 0, this whole piece is going to go to 0, because 3 times 0 is just 0. So you really have 2 times what is 6? 3. And then you have 0, 3. 0 on the x, 3 on the y, there it is. You're like, oh, okay, but that's only 2 points. That's all you need. Ta-da. Poof, line. Now, a third point is handy, but not necessary. So I'm probably going to get some blowback by teachers. Stop teaching them that. I'm only going to teach them what is true. So they're old enough, if they're learning this, they're old enough to know that you only need 2 points. But if you only use 2 points, really good chance when you're first learning to do this, you're going to screw up a lot. So the third point is there as a check. If the 3 don't agree, somebody's wrong. That's really it. The standard form of a line is this. Thank you. Stay put. The standard form of a line is this ax plus by equals c. So our 3x plus 2y equals 6. And where a, b, and c are all real numbers. This is only the real coordinate system, so we're not talking about complex graphs here. It is not necessary, but is considered good form. If you were to take, say you have fractions in the a or b or c slot, to multiply through by the least common denominator and clear those fractions. Why? I don't know, because people don't want fractions. We're inherently lazy people. Mathematicians want the easy way out. So easy numbers, yay. That doesn't mean you can't put the square root of 2 in for a. It's going to make your life a little miserable. So that's just the quick idea on standard form and working with the intercepts and how to use them to graph. All right, thanks for watching.